Hi everyone, we are looking at the transformations again. This time we're looking at all three kinds of transformations, our A value, the H value, and the K value, all put together and mixed in with the quadratic parent function. Just the quadratic, we're not doing square root. So we've got our quadratic equation there that we're going to be working with, our parent function. So let's break it down to what all those three different letters meant. So we're going to start with the A value. And again, these are just things to remember. So I'm going to zoom way in here on the A. All right, so first thing we talked about, when we have a positive A, if that A value is positive, then your quadratic parent function will open up. If that A value is negative, that's what makes the graph have the reflection, and it will open down. Now, the other thing we talked about is the actual number itself, not the positive, not the negative, but just the actual number itself, which we talked about is absolute value. If the absolute value of A is bigger than 1, we talked about last week how that meant your graph would be narrower than the original. We also talked about, to wrap up the A, if the absolute value of A was between 0 and 1, we talked about this meaning it was wider than the original, caused the graph to open up. So remember, big thing here with the narrower or wider means that whatever is inside those absolute value bars, we just want the positive version of that number. All right, so the next thing that we want to review just for a little bit is the H value, which is what's going on inside these parentheses. So let's talk about those for a second. All right, the x minus h, the whole thing squared, refers to the left or right shift, if you remember. So we found out that if we have x minus h squared inside those parentheses, we need to shift right. If we have x minus h squared, x plus h squared in those parentheses, that meant we need to shift left. This was the big one that we looked at, because we found out that insiders, meaning inside those parentheses, are going to lie. Okay, a minus does not mean go to the left like the negative numbers are, and a plus does not mean go to the right where your positive numbers are, because again, insiders lie when it comes to x minus h. The last thing that we looked at was the letter down at the end, the K. We found out that if we have a plus K, that meant we need to shift upwards. And if we have a minus K at the end, so we're subtracting that number at the end, that meant we shift down. And again, the big thing here is, since it is outside of these parentheses, outsiders are honest. Okay, outsiders are honest. So we're going to use all of this, use these little bits of reviews, and do it all together on one big quadratic. So let's take a look at our second page here and look at how we actually graph out some of these equations. So let's start with number 1. All right, so we're going to graph this, but we need to go back and remember those points. And just like I started with the A, giving you the different parts that it means, we're going to start with the A here as well. So right now, my A value is a positive 2. So that tells me a couple of things. That tells me that the graph will open up, and it should be more narrow than the original. So we're going to need to look at our original points here. So every parent function has the similar starting points, and for the quadratic, these are the points that we looked at last week, which was a -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. All right, so last week when we did the A, we talked about how whatever that A value is, we're going to multiply all of those Y numbers by that value. So in this case, by a 2. So when I do 4 times that 2, I have an 8. 1 times 2 is a 2. 0 times 2, still a 0. 1 times 2, a 2. And 4 times 2, a positive 8. So those new 5 points are the ones that we are going to graph. So for the moment, I'm going to go down to that grid and plot just those 5 points. I'm not going to connect them yet. I'm going to try to squeeze in as many as I can. So we had -2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we had -1, 2, 0, 0, +1, 2, and +2, and 8. So there's our first graph. Now, for the moment, I'm going to put up the original parent graph up here, and then I'll go back and erase it. But I want you guys just to see, is it in fact narrower than the original? And sure enough, it is. Those points right now are sitting inside that original graph. So now let's go up and look at our next set of transformations. That's just the A value. All right, so now let's look at the inside of the parentheses, our x minus h part. So inside the parentheses, we have x minus 3 squared. So insiders lie. Remember, if we have a minus, that means we're going to shift right. And in this case, since we have a -3, we're going to shift right 3. Outside of those parentheses, we had a -1. So the -1 is telling us about our k value. And a -1, outsiders are honest, so this time we are going to shift down. And it's a down 1 unit. So now to those 5 points that we have, we're going to take each one of them, shift them right 3 squares and down 1 square. So let's do that and see where our original graph is going to rest. So right 3, down 1. So I'm going to start with this first point up here at the top. I'm going to go right 3 squares, down 1. That's where my new point is. Then I'm going to do the same thing to the next one. So now I'm down at the second point, right 3, 1, 2, 3, down 1. Okay, 2 down, 3 to go. Same thing with this bottom point that we have here, right 3, 1, 2, 3, down 1. Okay, let's keep going. Our next point, 1, 2, 3, down 1. And our final point back up here, this top pink one, 1, 2, 3, down 1. All right, and there's our new points. So when I connect these, oops, sorry, didn't mean to erase there. When I connect these, there is my final graph. So if I erase all the old stuff, erase those original points, now I can see where my final shifted graph has become. So let's try it again. One more example. All right, so this time we have an A value, which is a -1/2. So those same 5 starting points are xy's. So a -2, 4, -1, 1, 0, 0, +1, 1, and +2, 4. So if my A is a 1/2, this time I'm going to multiply all 5 of those y numbers by a -1/2. Now, if it's easier to do the multiplication, you can always change that over to -0.5. All right, so let's get our new values here. All right, so 4 times a -1/2, -2. 1 times a -1/2, a -1/2. 0 times a -1/2, still a 0. 1 times a -1/2 again, another -1/2. And 4 times a negative half, negative 2. So those are the first points I want to go draw. All right, so we have negative 2, 2. So there's our first point. Negative 1 and a positive, I'm sorry, negative. Sorry, early in the morning here. Let me start that again. Negative 2, our first point. So there it is down in quadrant 4, I'm sorry, quadrant 3. Negative 1 and a negative half. So halfway down that space, 0, 0. Positive 1 and a negative half, and 2, negative 2. And if you notice right now, they are pointed down. And hence, anytime A is negative, it should open downwards. All right, so let's get the rest of our transformation so I know exactly where I need to move these points. All right, so inside these parentheses, I have x plus 2 squared. So that tells me I am going to shift insiders lie, so left 2. And let's get our last one. We have a plus 3 outside of those parentheses. Outsiders are honest, so this time I'm going to shift up 3. So let's do that. Left 2, up 3 to each of those points. So each of these left 2 and up 1, 2, 3. So there's my first point. So we've done that one, so I'm going to erase it, get it out of the way. Now we're going to do our next one, over 2, up 1, 2, 3. So just be careful when you're dealing with these halves, because you do have to stay on the little middle spaces. Okay, so we've done that one. Let's do our next one, over 2 and up 1, 2, 3. So far, so good. We did our one there. Let's do our fourth one, over 2, up 1, 2, 3. And then we'll get our last one, over 2 and up 1, 2, 3. All right, and there is our new function after the transformations have been done. All right, guys, I hope you enjoyed learning a little bit about how to graph an equation when you have all the transformations put together. Stay tuned for the second part of this. How do you write the equation when you have a graph? Bye, guys.